Okay, in this very first one here, we're going to look at a range of different functions and we're going to differentiate them. So we're going to be using a range of rules and laws, particularly log laws here as well, but we'll look at the chain rule, the product rule, and the quotient rule. So for the first one here, I'm going to have y is equal to ln 4x minus 9. So here, by using the rule that we just looked at before, which is this here, so if I have a function after the log, the first derivative will be on the top, and then the original function will be the denominator. So the first one here, I'll have the derivative of 4x minus 9, which will be 4. So dy dx is equal to 4 over that function of 4x minus 9. In question B, we're going to approach it very similarly. We're going to have y is equal to ln 4 plus x squared. Okay, so if I was to derive that function, I would have 2x as the numerator, because that's the derivative of that, over 4 plus x squared. Okay, so that's the first two done. Now let's have a look at question C, which is ln, and then we're going to have ln x. Okay, so here, if I were to derive this function up here, okay, I'd actually get 1 on x, okay, and then I'm going to have the original function ln x. Now, if I were to put ln x as a fraction, I would have this. So for two fractions, if I'm dividing them, I'll flip the bottom and multiply, so I'll have 1 on x multiplied by 1 on ln x. So this here, the answer to question C would be 1 over x ln x. Okay. Very good. Let's have a good look at question D. Now here we're going to use the product rule, because I've got two functions. I've got x cubed and y equals ln x. So here y is equal to x cubed multiplied by ln x. Okay, so let u is equal to x cubed. Deriving that, I'd get 3x squared. Here I'd let v equal ln x, and v dash being 1 on x. So I'm going to look at my insides and outsides. I'm going to multiply them and add them together. So here I'll get, if I look at uv dash, so y dash is x cubed over x plus 3x squared plus, multiplied by ln x. So here the x cubed on x will become x squared plus 3x squared ln x. Now, it is useful to factorize, particularly if I'm looking for any stationary points. So here I'm going to take a factor of x squared out, so I'll have 1 plus 3 ln x as my solution to question D. So for question E, looks a lot more complicated, so let's do it over here, but it's actually okay. So I'm going to have y is equal to ln, and then I'm going to have two fractions here, 1 plus x all squared over 1 minus x all squared. Alright, so for this one here, I'm actually going to use my log laws. So if I have a division here, I'm actually going to subtract these two. So I'll have this as y equals ln and then the numerator, 1 plus x squared, okay, and then I'm going to subtract ln 1 minus x all squared. Now here I could also use the log law that the 2's will come down and be the coefficient of the log. So here this will actually be 2 ln 1 plus x minus 2 ln 1 minus x. Now I can easily differentiate this. So here I'm going to go dy dx So I'm going to derive this part here, and that will become my numerator, so 1 plus x. The derivative is 1, but remember I have this multiplier of 2 out the front, so it's going to be 2 multiplied by 1 over the function in there, which would be 1 plus x, minus 2, because I have this here, times deriving this, so that'll be negative 1, over 1 minus x. Let's simplify this a little bit. So I'm going to have that as 2 over 1 plus x. Okay, so this is actually going to be a positive because I've got the two negatives. So I'll have plus 2 on 1 minus x. Okay, now there's a few things I can do here. I could actually take a factor out if I want, and then make a common denominator, or I could leave as is. But I might actually put on the one denominator. So here I'll take a 2 out, and then I'll have 1 minus x plus 1 plus x all over a common denominator of 1 plus x, 1 minus x. Okay, so simplifying the top there, so I'll have 2, and then I'll have 2 over 1 plus x and 1 minus x. Alright, so that actually ends up being a nice solution of 4. Okay, so I'll get 4 over 1 plus x, 1 minus x. Brilliant. Okay, so we've only got one more to do now, so that is question F, which is y is equal to e to the x squared ln x. Okay. So here, I'm going to use my product rule again. I'm going to have u as e to the x squared. Deriving that would give 2x e to the x squared. Now, v being ln x, so v here would be ln x. Deriving that gives me 1 on x. So insides and outsides, and using the product rule. So here, y dash would become, if I did u v dash first, I'd have e to the x squared over x plus 2x e to the x squared ln x. Okay, so here I can factorize an e to the x squared out. Okay, and that'll give 1 on x plus 2x ln x. Now, what I could actually even further do is I could actually take this denominator of an x out. So here, to get that denominator over on the right hand side here, I'd have to times this by x on x, okay? And when I do that, I can take the x out. So here, I'll have e to the x squared over x. Now, I'll just have a 1 at the start here, and then I'll go plus 2x squared ln x. Very nice solution there for question F. Okay, so that's all of the working for example 1.8.